Thanks. So some of you guys might know me, some of you don't. I just have a lot of history within the DoD, especially JIT community, as far as doing a lot of test and evaluation. And part of that was actually doing a lot of experimentation testing as well as interoperability, functionality, performance testing of IPv6. So what I wanted to talk to you about today was integrating or actually doing IPv6 test and evaluation in the enterprise. So to kind of disagree with Stan to that part, that there's a part of that is of implementing and transitioning is doing testing. So test evaluation is a huge part of kind of transitioning your networks in. So what I want to kind of talk about is why is enterprise level IPv6 integration tested really needed? When the testing's really got to happen, what type of testing needs to be done, and then really kind of help you kind of develop your own test and evaluation master plan when it comes to IPv6. So the number one reason, obviously, is you don't want that kind of discontinuity or your discontinuation event to happen to you, right? So you don't want this to happen to your live business systems. So when I start talking about some of this integration testing, we're looking at your network's transitioned, or you're looking at your transitioning your network. Now, how are you integrating your systems in? And those systems can be applications, business systems, homegrown systems, things like that. And so one of the things we talk about in testing is there's a lot of the guts and the plumbing of the internet. They've taken care of a lot of that stuff as far as testing has been going. So you think NIST in their program with the USGV6, DoD, IPv6 ready, a lot of that stuff's been done. But what you really want to look at is those layers from layer 7 to layer 9, obviously. I mean, they don't really exist, obviously, layer 8 and 9, but from a theoretical perspective, every one of you have dealt with layers 8 and 9, especially when you come to deal with business applications that have to do this, or some fire you have to put out and things like that. So that's a key component of what you don't want to happen to your network, or you don't want to happen to your business application. So in a lot of the experiences that we've had, we've run into specific things where if you didn't do the testing or you didn't do some sort of evaluation of IPv6 in your network, you're going to see things that are a little odd. So there's little hiccups into specific applications or systems that are in these networks. So the first one, obviously, everybody knows about XP and its deficiency in doing DNS resolution over IPv6. And then Windows 7 defaulting to IPv6 only home groups. I mean, you actually have to physically make that change if you're doing that. Web-based Java applications not listening on IPv6, and that's basically how you start the application, especially JBoss and other things. A lot of it defaults to listening only on IPv4, so you got to look at that, right? So that's one of those things you look at. A lot of those homegrown C++, .NET applications that everybody just hand jammed in an IPv4 address. They can't really configure the address, and they can't accept an IPv6 connection. And then what about database connections? There's a lot of databases out there that people use that are really old databases, whether you're talking about really old Oracle databases or whatnot that will only have connections over IPv4. Those are things to look at. And then obviously SNMP v3 implementations that are done only on IPv4. That's common in a lot of the network management systems right now. Other ones are, firewalls aren't really firing identically on IPv6 related rules or IPv4 related rules. So you think you're, just like an IDS is looking at denial of services attacks, SYN floods, even from malware, tunneling, things like that. They're looking at it from an IPv4 perspective, and they haven't really rolled in the similar checks to looking at IPv6. Those are things like, again, your system you need to look at. And then not many people know that there's a different way in how things are implemented when it comes to stateless address auto configuration in DHCPv6. There's a huge religious debate in the IETF of should you push out route advertisements and be on auto configuration, or should you do configuration over DHCPv6. So a lot of network operators need to understand that you need to be aware that you have to have some support for both in your kind of scenario. And then there's a lot of network layer gaps too. One on there is that I've discovered recently is that certain router vendors, will do VRF Lite for IPv6, but they won't route over OSPF v3. which you think, I just needed that one extra step, you didn't have that. Or things that are doing a lack of wide RA guard, which is, Cisco, this is Cisco language, of course, but how they basically will block malevolent or dangerous folks that are putting in route advertisements on the network and things like that aren't obviously your router. And then obviously IPsec isn't automatically there, right? So that's one of the misnomers in IPv6 is that, IPsec is mandatory, and it's not necessarily the case, and especially in a lot of business applications that need to use it. Other things that we've noticed is that, one that I didn't put on the slide here was actually VPN concentrators, virtual desktop services. You think there's a point in which the connections aren't exactly made over IPv6. And that's just discovery that I've done in the last 6 months on a deployment that we're looking at right now. So what do you look at? When does this testing need to occur? So you look at, obviously, towards the bottom there. You really want to develop an IPv6 architecture. So we've heard a lot about transition plans, kind of how to request address space. You need to build a design for IPv6. And that really comes down to what your as-is architecture is now and what you want IPv6 to do in your architecture. That's things about answering questions about routing. How are you going to do IPv6 routing with v4 in the mix? Do you want to route IPv6 over v4 routing protocols? Do you want to do things that are using stateless auto configuration, or do you want to use DHCPv6? These are all kinds of questions you need to answer in an architecture so that you can actually test that. And then obviously writing in a transition plan. And then moving on, then you want to actually write and communicate your test and evaluation master plan. And now that I'm going to talk about later in this presentation about kind of what you need to include in there, but that's basically instructions to your network folks, or actually your system owners, what you expect of them to demonstrate as far as what you're going to be testing on them and what they need to be tested on. Okay, so part of that is, what do you need your teeny integration lab to look like for v6? Tony brought up a really great point, and I wanted to highlight that here, was that shutting off IPv4, right? You want your as-is architecture, you want to mimic it, or you want to mimic it and you want to shut off IPv4. You want it only IPv6, right? So that's it, IPv6 only part. So it's mirroring your IPv4 only, but you're looking at it and actually disabling IPv4 across the board. And you're going to find out a lot of things. You're going to find out crazy things like DNS resolutions are failing, or you're going to have connection problems, network management problems, things that you didn't think about ahead of time that you're actually going to roll through when you test. And then you want to actually find those failures, of course, and you were looking at, and that's where we have a dual stack configuration to help with that. And your as is IPv4 only. A lot of that is mainly for legacy systems, legacy users. You're going to have a Windows NT server that's out there. You need to see how it integrates into your IPv6 infrastructure, things like that. I'm going to talk a little bit more in detail on what those are. So it's just a quick drawing that you can kind of look at your own time. Just kind of how you should integrate that stuff. And then you see routers there. Those could be virtual interfaces. Those could be a switch. Those could be 4 or 5 different switches that you have. But it's mainly from the aspect of you're looking at an IPv4 only, dual stacked IPv4 only, and then some sort of a translation between your two IPv4 to IPv6. And then obviously on the back end of that is all your internal enterprise services. Now what kind of testing though? So you see, you want a pre-test assessment, right? So you're doing that look at the system and you're going, okay, now I'm going to walk through my system. What do I know about ahead of time that I'm going to have issues with? Write that down. Identify that well ahead of time. And then you're going to walk into a functionality integration standpoint, interoperability. That's where you want to actually, do more functional-based tests in your system and your applications. Things like, can I get to the web server? Can I do a DNS resolution? Things like that. And then you have some sort of a subset of performance testing. Now, from intermediate devices, that's usually like, throughput, latency kind of tests. And then from endpoints, that's usually, TCP sessions, things like that. And then you want to look at security, and that's a huge part, and that could be a very involving part. It's basically doing a pen test on your whole network in an IPv6 only configuration, and what kind of problems you're going to have, because you're going to identify a few. And then I won't steal Joe's thunder. He's going to talk all about that later today. And then you want to do a post-test documentation, an after action, if you will. Something that basically goes, here's where I stood, this is where I thought I stood, this is what happened in the testing, and then basically this is my result from that. So in that pre-test assessment, basically gathering your COTS vendors, your test engineers, your systems engineers, everybody in a room basically to say, this is your test plan strategy. This is what you want to basically solicit your capabilities at that point and how you want the organization's IPv6 or how you want their system to actually interplay into the organization's IPv6 architecture. And then basically, you're going to talk through a lot of those test procedures. You're going to say, this is what we're going to test. This is how we're going to test it. And if you know ahead of time, like I said earlier, if you know of any IPv4 dependencies, identify those then. And then you want to identify success criteria. Do you want this to be a pass or fail? Do you want this to be information only? Things like that. Okay, so basically from the functionality interoperability standpoint, like I was saying, focus your test on user stories, end-to-end operation. Things like your workstation needs to connect to your Exchange server and it uses MAPI, right? You want to make sure that end-to-end function of it working over IPv6 works correctly. Or the encrypted function of talking DNSSEC, for example, or SSL for an SSL VPN concentrator, things like that. Develop those user stories as you develop your test cases. And you want to document your failures. Obviously, every part of this is documenting pieces and parts of this, so that when you wrap this all up, you know what you either need to fix, you need to mitigate, or you need to at least identify. And then the idea of the dual stack network now is looking at repeating those test cases in IPv4, or I'm sorry, in the dual stack network. So the test cases that failed in IPv6 only, now doing it in a dual stack, then you've identified some linkage that you have a dependency in v4. And then ensure your IPv4 only users still have functional users of the system over IPv4. That's key. Okay. And then, like I said, with performance testing, from your basically system applications standpoint, you're looking at capturing your TCP sessions, your concurrent TCP sessions, kind of doing it from you're doing it in IPv6, now you're doing it in IPv4, or you're doing it in IPv4, and you're getting a baseline, and from that point, do it at IPv6 and kind of see where you stand as far as what problems you're going to have. You're going to capture the latency, obviously, on that, and then throughput on intermediate devices, like I was saying. And you want to do this basically repeating that over an IPv6 only and a dual stacked infrastructure. And you really want to identify this so that you can say, these are the risks that we have going with the system in an IPv6 only configuration. This is what it's going to look like in dual stack, and of course what it's going to look like in v4. Okay, so like I said, the most involving part of this testing is going to be security. You're probably going to scare yourself while you're doing some of this testing. You're going to realize how vulnerable you are in a lot of situations, and there's a lot of documentation from a lot of folks out there who've done a lot of hard work into. Joe's one of those, obviously, and there's a few others in the room that have done a lot of work to see, what problems there are. Now you've identified. Now you have a dual stack network. Now you have new vulnerabilities you've opened up. And some of the things, and there's a lot of tools out there that can't help you. And I thought I'd just throw those out here, and if you're a vendor with one of these, I'm sorry. Basically, you're not going to find any support for IPv6 right now. I know at some point they have future of having the support for that, but that right now they don't. Nessus, some limited IPv6 capabilities, and maybe Joe would argue with me on that one, and then OpenVAS has no, or OpenVAS doesn't have any IPv6 support as well. Now there are some better tools, right? And I'm not just saying this because they're one of the sponsors here, but Mu Dynamics actually has a pretty good tool set that they actually, can generate test cases, sniff it, repeat it, stuff like that that'll actually work real well. And then open source usually always wins in those kind of scenarios, especially when it comes to security testing. Things like Nmap, Scapy, Netcat, John the Ripper, things like that. All those function really well over IPv6. And then one that I haven't actually heard much about in the past, but they were actually really good, at least on the outset of testing, was Spirent's ThreatX. They actually did a really good job at some point. I'm not sure where they are now. But. And so basically you want to mirror your scans, right? You want intrusion, detection, and everything. All those tests you want focused around IPv6. And you want to basically run a lot of the security testing, pen testing, whether it be scanning, things like that you're doing over IPv4, you want to do that same thing over IPv6. And then you also want to test for new vulnerabilities, right? So some of the things that are out there like IPv6 and 4 tunneling over UDP, over all kinds of different mechanisms, HTTPS, things like that. And the innumerable problems and issues with a lot of the extension headers in IPv6. Again, those are things to include within your testing for security. And then, of course, document those results, right? So you want to have that documented. And really, you want to basically set this whole system up to, document this, do some sort of a post-assessment, hot wash, after action, whatever you call it, to where your system owners really have a good idea of when they're going to integrate this stuff into your enterprise network, they know what they're going to deal with, right? They know, how they're, where they're going to fall on performance, where they're going to fall on security, where they're going to fall on functional dependencies, so that they can make proper adjustments ahead of time before actually rolling these systems and applications into the enterprise. So. Any questions so far? I want to jump into a test evaluation master plan. I think I have a little bit more time here. Yep. Not automatically, right? So, and that's in a lot of cases, and that's not in a lot of cases, right? From your Linux and your Unix and your Windows desktop platforms, some of that is. It's not all done in IPv2, and some of it isn't, right? A lot of your network appliances don't do IPsec, especially connections termination directly on them over IPv6, right? So, yeah. So are you talking about the security testing specifically? Yeah. In fact, a lot of that stuff that I talked about, some of those things that were brought up. In fact, Joe worked a lot with the DoD's IPv6 transition office. What's that? Okay. Sorry, man. I don't know what to tell you. Yeah. Yeah, I hear you. So, DICAP is a part of the DoD's way in which they do accreditations internally with local DAAs and things like that. It's a good process. IPv6 hasn't been a part of it, and there's very few functions, especially security-related things that are actually in the STIGs, if you want to call them. So they're just not there. Right? So moving along here. Yeah. Say again, I'm sorry? Right, so really you want to put your system in an IPv4, or I'm sorry, IPv6 only environment. Yeah, so in that case, our DSCP links or everybody should be on IPv6, right? So we will disable there also, right? Right, obviously DHCPv6 isn't going to work in an IPv4 only environment, obviously. So that's a different, that's set up as a different function, obviously. But from application standpoints, I've got a web server, I've got a database server, and it's all part of my integrated system that I'm employing in this enterprise architecture. And I do an evaluation on it, and I shut off v4 on there. From that standpoint, you're going to really realize, what kind of problems and hangups you're going to have without v4 there. Was that your question? Okay. Well, again, I'm not working with compliance, right? So that's a heavy word what you just threw out there, right? From the standpoint of what your enterprise architecture that you built and you designed for your enterprise architecture, not necessarily one device has to be capable of doing these RFCs, but what you want your enterprise architecture to do, that's what you need to evaluate against, right? So that's up to you, right? So I'm kind of giving you what you really should look at, and in the process of, if these things really do matter to you and they're critical things to where your system needs to do that, then that's where your application crew needs to go back and start rewriting and adding the functionality. Or it's to say, these failures, you say you isolate them and put them in an IPv4 only kind of an enclave, if you will. You know what I mean? So that's really kind of up to you as far as the enterprise goes. Okay, so, yeah. I'm sorry, I didn't hear that. So that was really just a visual representation, right? That could be a switch, that could be a Linux box that acts as a router, things like that, right? So I was just doing a visual representation of kind of isolating your enterprise architecture in your test environment of what, this is IPv6 only, this is IPv4 only, this is dual stack, this is kind of how you can do routing between the two if you're doing routing, things like that. Does that answer your question? So usually that's not very good practice, right? So whatever the router is actually functioning in a specific VLAN or whether it's the enclave itself, you really want to only have one RA actually being generated at that point. And that's where I talked about RA guard, which is some of those things out there can guard against having multiple RAs because you don't want that, right? You don't want multiple routers in your network routing you all. It's kind of a big vulnerability, right? So, yeah. Okay, so I'm just going to move into here. So kind of developing a test evaluation master plan, right? Kind of goes into some of that stuff with the ITIL process, things as you're kind of looking through, doing enterprise architecture, now you want to basically communicate how you want your system owners and your application owners to do that, to kind of help you test through this process. And you want to design it with their stakeholder input, right? You don't obviously want to do this on your own. And you really need to know your organization, the processes, the people involved, the hoops you have to jump through. And you really want to develop a simple process. And if it can basically hook on to, just like Stan was talking about, if you can hook on to a process that's already built in there, do that. Right? If you don't have a process, maybe this is your time to build one. So at that point, you really want to, the first kind of step is defining roles and responsibility. Who approves your tests, who approves the results, who tests, who schedules. And then you basically, at that point, you want to actually develop your test architecture and design the process at that point. So again, if you're, it's not the 90s, or if it is the 90s, things like that. And then define your high-level success criteria. And that's where you come to actually, writing those generic test procedures. You want to work with your vendors around that. You want to work with the stakeholders in that. Those are where you talk about those end user stories. You have a generic set, like this is how we want to see performance set up, and this is our success criteria from a generic set. And you want to say, well, what's in your system? Is your system comprised of a web server, maybe a database server, things like that? It's separated within a DMZ architecture. How do you do that? How do we want to arrange that user story? Because you're going to do it in an IPv6 only environment, and then you're going to do it right there in an IPv4 and dual stacked environment as well. But then you want to communicate this, right? So you can do all this work and things like that, but if you don't communicate this, your users, more like your system owners, aren't really going to understand this, and especially not understand the need. So basically, that was a test and evaluation master plan. I mean, it's functionally, there's a lot of information in there, but it's definitely something you need to put together and develop as you deal with this testing. But anyway, so I talked about enterprise level IPv6 testing, right? So from the aspect of an enterprise network, it could be your home network. It could be, your small business network from a little microcosm of what I'm talking about. But functionally, the infrastructure and the testing is functionally the same, right? And you want it to be that way. You want your applications to be, looked at that way. We talked about when the testing's got to be done, how the testing should be done, and then basically developing that test evaluation master plan. And if anybody in here is actually part of a DoD network, I do a lot of work with them, and I can hand off a lot of stuff to you to kind of help you through some of that stuff. Just get with me later on that. So, And then basically, what you don't want in your IPv6 deployment is more frustrated users. And in virtually every enterprise you come into, it doesn't matter. Every user's frustrated and they're angry about something in their network. What you don't want is IPv6 to be another reason why they hate you in that. So, any other questions? Yes. Yeah, sorry about that. So, acronyms, right? So, commercial off the shelf, right? So, stuff that's like a Cisco router or a Red Hat Enterprise Linux server, things like that. And that's not your generated, it's not a user-generated application or something like that. All right, any other questions? Okay, thanks a lot.